Okay, when I say black hole, what's the first thing that pops into your head? Probably some kind of cosmic monster, right? A vortex of pure destruction, basically a giant vacuum cleaner just gobbling up everything in its path. But what if I told you that the most destructive things in the entire universe are also the most creative? In this explainer, we're going to flip that old image on its head. We're diving into one of the biggest, most profound revelations in modern astrophysics. And the question at the heart of it all is pretty simple, but it changes everything. Are black holes really the ultimate destroyers, or are they actually the essential creators?
You know, for decades, that myth on the left, the cosmic vacuum cleaner, that was the story, that was the science. But a completely new and frankly, much cooler picture has emerged. The new reality is that these gravitational titans aren't just cosmic accidents. They are fundamental architects, absolutely essential for building the very galaxies we see all around us.
So where's the evidence for this, right? Well, it all starts with something astronomers call the cosmic census. It's like a survey of the entire universe, and it's revealed an unbreakable rule about how galaxies are put together.
And what's just incredible is how universal this is. We're not talking about a few weirdo galaxies here and there. Nope, this is a standard feature. Our own Milky Way? It has one, Sagittarius A star. The Andromeda galaxy next door? It has one too. For pretty much any big galaxy, having a supermassive black hole in the middle is the rule, not the exception.
And we are absolutely positive they're there. I mean, the evidence is just overwhelming. We can literally watch stars whipping around an invisible, super heavy point at insane speeds. We can measure gas as it swirls down into that central abyss. And now, get this, thanks to the Event Horizon Telescope, we can actually take a direct picture of their shadow. There's no doubt anymore. Think about that for a second. When nature repeats the same pattern across billions of galaxies over billions of years, that is not a coincidence. That's a massive clue. It's telling us something fundamental. So the question for astronomers has totally changed. It's not if galaxies have black holes anymore, it's why they absolutely seem to need them.
And that leads us to one of their most important jobs. They act as a kind of galactic thermostat, a powerful regulator of creation that reaches across hundreds of thousands of light years.
Now, the sciencey term for this is AGN feedback. AGN just stands for active galactic nucleus, which is really just a fancy way of saying the black hole is on and it's eating. And when it eats, it's not a quiet meal. It unleashes a truly staggering amount of energy that affects the entire galaxy.
So here's how this thermostat actually works. First, gas from all over the galaxy starts falling toward the black hole. This gas forms this spinning, superheated platter called an accretion disk. That disk then erupts with incredibly powerful radiation and jets of particles that shoot out at nearly the speed of light. And finally, this massive energy blast plows into the galaxy's gas clouds, either heating them up or just blowing them away, which effectively slams the brakes on star formation.
And why is that so important? Well, without this feedback loop, galaxies would be like an engine with the throttle stuck wide open. They just burn through all their gas in one giant, chaotic firestorm of star birth, and then completely fizzle out. The black hole is what enforces order. It makes sure things happen at a sustainable pace.
Okay, so they're everywhere, and they act like thermostats. But what's the smoking gun? What's that definitive piece of evidence that proves this partnership is real? Well, that brings us to something amazing called the M-sigma relationship.
This was discovered back in the early 2000s, and it's one of the most important findings in all of astrophysics. What it shows is that a black hole's mass is tied directly to how fast the stars are moving around in the galaxy's central hub, or its bulge. And this connection isn't just kind of sort of there, it's incredibly precise across all sorts of different galaxies. Now here's the part that is just going to blow your mind. Look at that number. A supermassive black hole only makes up a tiny, tiny fraction of its galaxy's total mass, about 0.2%. It's like a single grain of sand on a huge beach, yet its influence is so profound that its size is perfectly synced up with the behavior of the entire central region of the galaxy. How is that possible?
The implication here is just staggering. I mean, let that sink in. It's like the black hole somehow knows what's happening thousands of light years away. Its own gravity can't explain that. The only way this works is if they have a shared history, if they literally grew up together through this constant back-and-forth feedback loop.
And that's the bottom line. This M-sigma relationship proves coevolution. They're a package deal. A galaxy and its black hole aren't just roommates that happen to live in the same space. They are two parts of a single connected system that build each other over billions and billions of years. All right,
So let's put all the pieces together and look at the full picture. The black hole as a true cosmic architect.
So we've talked a lot about that thermostat role, right? But their job description is way bigger than that. They were probably the original seeds that kicked off galaxy formation in the early universe. They stopped the biggest galaxies from getting way too bloated and oversized, what you could call galactic obesity. They even play conductor when two galaxies collide and merge. And by doing all of this, they help create that beautiful, rich diversity of galaxies we see across the cosmos.
This really gets us to the ultimate question if we want to understand just how important they are. Let's do a little thought experiment. What would the universe actually look like if black holes just didn't exist? Well, our best computer simulations give us a pretty clear and pretty weird answer. Without black holes and all their feedback, galaxies would be these strange, unrealistic things. They'd become these supermassive, crazy dense blue nuggets that form all of their stars at once in a flash and then just burn out. In other words, the universe wouldn't look anything like our universe.
And I think this quote just perfectly captures this new reality. Black holes aren't the villains of the cosmic story. They're essential partners, locked in this intricate evolutionary dance with their galaxies for billions of years. So the next time you look up at the night sky, just remember that those beautiful, majestic galaxies wouldn't be there, at least not as we know them, without that supermassive black hole hiding right at their heart, the silent architect in the abyss.